video, we're going to learn some techniques to factor polynomials. First, some review, what polynomials are, and then we're going to show you division of polynomials. Lastly, use synthetic division to streamline our work. First, what is a polynomial? Polynomials consist of variables that are added or subtracted. Only zero or positive integer exponents are allowed. Roots, reciprocals, and exponents with variables in them are not allowed. We're going to review for division of polynomials by taking the simple example 172 divided by 4. And we're going to use long division, and I'm going to show you the steps quickly. Four is the divisor, 43 is called the quotient, and 0 here is the remainder. So we can say that 172 is the same as 4 times 43. We say that 172 is divisible by 4 and divisible by 43. Both 4 and 43 are called factors of 172. Let's compare this now to a polynomial x squared plus 4x plus 3 and divide it by x plus 1. In the same way, we're going to set x plus 1 as the divisor, and we're going to set up the long division problem. We're going to ask ourselves, x times what number gives us x squared? Well, of course, that would be x. X times x is x squared. So we're going to set up the multiplication here, x times x plus 1, and put the answer in below. Next, we're going to subtract. A reminder, to subtract, add the opposite. For instance, 6 minus 5 is 6 plus negative 5. X minus x plus 1, x plus negative 1, resulting in negative 1. Now, x minus negative 1 in brackets is the same as x plus negative x plus positive 1. Resulting in the answer positive 1. So to avoid these negative sign errors, just make sure that you add the opposite. I'm flipping the signs of x squared plus 1x to negative x squared plus negative 1x. 4x plus negative 1x is positive 3x. Then I bring down the positive 3 and ask myself, x times what number gives me 3x? And the answer, of course, is 3, which I put above the 3. Now I need to multiply 3 times the divisor x plus 1 in order to find out if I have any remainder. 3 times x plus 1 is 3x plus 3. Now I have to add the opposite to subtract, and I get 0 remainder. So we say that the polynomial x squared plus 4x plus 3 is equal to x plus 1 times x plus 3. The binomials x plus 1 and x plus 3 are factors of the polynomial because the remainder is equal to 0. In other words, they divide exactly. In a similar way, x plus 1 is called the divisor, x plus 3 is the quotient, and 0 is the remainder. If the remainder is 0, that means the divisor and the quotient are factors of our polynomial. What happens then if there is a remainder? Here are 2 examples that I'm going to solve quickly for you, and you can see for yourself what will happen. We can form division statements to summarize the problems. 173 is 4 times 43 plus a remainder of 1. X squared plus 2x minus 4 is equal to x minus 1 times x plus 3 minus 1. The polynomial is equal to its divisor times its quotient plus its remainder. Or, in other words, p of x equals d of x plus q of x plus r of x. In the previous examples, we divided trinomials by binomials. In the first instance, we had 0 remainder, and that meant the divisor and the quotient were factors. In the second example, they were not because the remainder was not equal to 0. Let's extend our technique to higher degree polynomials. Here is a fifth-degree polynomial written in a scrambled order, and rewrite our polynomial in descending powers of x. Our divisor is going to be x minus 1. Now I'm ready for long division. Press pause now and try this question on your own. I'm just going to speed up the process for you. At any time you may stop the video to check over the steps. Don't forget, when subtracting, add the opposite. In other words, flip the sign and then add. The division statement for this problem is x to the fifth plus 2x to the fourth minus 7x cubed minus 8x squared plus 12x plus 1 is x minus 1 times x to the fourth plus 3x cubed minus 4x squared minus 12x plus 0 plus a remainder of 1. Pause now and try one or two questions from your work text. You've chosen to continue on with synthetic division. Now this requires that you pay special attention to what I'm doing. There's a lot of extra stuff on this screen that I do not want. I'm erasing all of my multiplications that I've got on the side. Next, I'm going to focus on the key numbers. The 1 in the divisor, the coefficients in the polynomial 1, positive 2, negative 7, negative 8, positive 12, and positive 1. Next, I'm going to look at the key parts of the subtraction. It's tiring writing out all those variables, x's, and their powers, so I'm going to erase the x to the fifth, x to the fourth, all the x cubes, the x squareds, the x's. Next, I'm going to eliminate the numbers that resulted in a 0 difference. That sure looks a lot cleaner than before. Instead of bringing down, let's take these up. Remember when I changed signs and added? Well, I don't think I need this x minus anymore. And look at this. This line of numbers is the same as this as long as I bring down this 1. So I will erase the top line and use the bottom line to represent the answer. This is called synthetic division, and you're probably wondering, what happened to all my numbers? So here I will just go over it again and show you the steps. Here is my original fifth-degree polynomial divided by x minus 1. I write down the 1 from the x minus 1 division bracket, write down the coefficients 1, 2, negative 7, negative 8, 12, and 1. I drop the leading coefficient below the line. Next, I multiply the divisor by this coefficient. I add the 2 plus 1 to get 3. Then I repeat 1 times 3 to get 3. I write it under the next coefficient, add it to negative 7 to get negative 4. I write negative 4 under the negative 8, add to get negative 12. Multiply negative 12 by positive 1 to get negative 12. Add to give 0. Transfer the 0 under the last coefficient and add to get my remainder. So my original polynomial, 1x to the fifth plus 2x to the fourth minus 7x to the third minus 8x to the second plus 12x plus 1. So when our polynomial is divided by x minus 1, we get the division statement x minus 1 times 1x to the fourth plus 3x cubed plus 4x squared minus 12x, no constant term, plus a remainder of 1. Watch this video again if necessary. In class, we will practice some more and we'll answer your questions.